XE Solar is inventing solutions at very small scales that will help meet needs at very large scales. Specifically, to meet the huge and growing demands for energy, we're creating concentrating solar power systems that can scale to the planetary level. These systems make the most efficient possible use of land area. The design emphasizes common, abundant, inexpensive materials, not limited by scarcity or restricted foreign markets. They combine innovative ideas in photovoltaic cell physics, concentration, tracking, and area-filling panels to reach new levels of performance. They're appropriate for deployment in the largest utility-scale arrays, where their site-adaptive coloring helps them blend into the landscape, on urban rooftops, and incorporated directly in architecture, where they can achieve striking color effects. We'd like you to understand why we're investing our product design and research efforts on concentrating photovoltaics. It's because of the scale of the challenges we face nationally and globally. The expansion of energy demand is relentless, from roughly 15 terawatts worldwide today to double that amount just 4 decades from now. It's imperative that we start scaling up long-term renewable sources now. But where should we focus our efforts? Which renewables are actually capable of scaling large enough to meet our needs? One very important way to compare renewables is by their area efficiency, how much energy they can produce on the land they take up. At the low end are geothermal and most kinds of biofuels. At the high end are the most advanced kinds of solar power. Why is area efficiency so important? Because the scale is so large. With renewables, you have to gather diffuse energy over large areas, and the total amount of area needed can become huge. Here's a quick thought experiment. Take conventional wind power and try to scale it up large enough so that it can completely supply the energy needs of a country of 500 million people, the projected population of the US in 30 years. You would have to set aside more than 2.5 million square kilometers for wind farms. Or suppose you were to try to supply that much energy with ethanol from sugarcane, one of the most efficient biofuels. You'd have to plant more than 8 million square kilometers. Clearly, to meet our basic demands for energy, sources with much higher area efficiency are going to be required. Because we want to stay with renewables, let's look up at the other end of the area efficiency scale, the different variations of solar power. For reference, here's the single crystal silicon flat panel that you would find today on the rooftop. What are other solar options? Right now we're hearing a lot about thin film photovoltaics, which are somewhat less efficient. In their favor, they promise to be less expensive to manufacture, but they require some very rare materials that are already tied up in restricted international markets. This could become a hard limit that will prevent them from reaching a national, let alone planetary, scale. Next, the large mechanical tracking systems. Tracking the sun is an important concept, and this approach does achieve good optical alignment. But today's systems fall short of the area efficiency of conventional flat panels filling the same footprint of land. Why? Because so much of the sunlight is wasted on the empty buffer zones required for maintenance and for keeping the moving panels from running into each other and casting shadows on each other. Solar concentrators also have great potential, but so far the area efficiency of these systems still falls short of filling the same area with conventional flat panels. But what if you could somehow combine the best features of flat panels and the concepts of tracking and concentration, yet avoid their shortcomings? That is exactly the approach that we're taking at XE Solar. That's how we will achieve these high area efficiency ratings that would allow the country to be powered from a much smaller area of land where the sunlight is the strongest. XE Solar panels completely fill the area and intercept all of the direct sunlight. Innovative optoelectronics shrink a complete tracking system down to fit within the top layers of glass, and miniature high-gain concentrators intensify the sunlight 500 times and focus it on specialized high-intensity cells. What's more, research underway at XE will take our area efficiency much higher still, with a new generation of nanostructured supercells. Constructed of abundant, economical materials, these are truly systems that can scale to meet the challenges. Now, let's take a closer look at 3 revolutionary aspects of XE's solar initiative: the trackers, the concentrators, and very advanced solar cells. Let's start with the concentrators. In every square meter, there are about 1,600 of these. Unlike ordinary lenses, these don't work by just refracting the light. They also work by reflecting the light on a folded path. No metallic coatings or mirrors are required. Total internal reflection in the glass itself concentrates the light 500 times on the central cavity which holds the solar cell. Let's move to tracking. If we want to avoid the shortcomings of large 2-axis mechanical trackers, an elegant solution is to miniaturize the tracking component and embed it in the panel. The XE Sunstalker tracker is completely contained in these thin glass layers. This allows the panels to stay flat in the array, to completely fill the area, and to be sealed against weather and dust. Internally, the tracking layer is an innovative fusion of XE's optics and drive mechanism with advanced transparent electronics techniques obtained under a technology collaboration and licensing agreement with Hewlett-Packard. Instead of using conventional motors and gears, the rotors are directly positioned by digitally controlled internal electrostatic attraction and repulsion. The static charges are induced by transparent electrodes printed onto the surface of the glass. This makes the mechanism extremely simple and durable. It also makes it easier to mass produce using techniques already refined for making display screens. Sunlight coming in at an angle is intercepted by the tracking layers and steered straight into the concentrators. At the focal point of all that concentrated light is the high-efficiency solar cell. Compare its size to a conventional silicon solar panel, in which a lot of active material is used to cover as much of its surface as possible. In contrast, using the XE Sunrise concentrators allows us to reduce coverage to only 1/500th of the surface, and to use cell technologies optimized for high intensity on very small cells. The overall result is much higher total output at much lower cost. Today, these are broad-spectrum multi-junction solar cells, about twice as efficient as conventional silicon. But if we had even better cells, our concentrator-based design could drive efficiency much higher still. So, XE Solar is undertaking a parallel research initiative to create a fundamentally new kind of solar cell, the Surface Plasmon Enhanced Rectification Solar Cell, or supercell for short. Each supercell consists of a very thin metal surface, under which is located a layer of millions of nanoscale cavities, each containing a very sharp-tipped cathode, an anode, and a gap. These structures serve as nanoscale vacuum tubes. The energy of intensified sunlight drives strong resonant excitations on the inside surface of these cavities. The excitations are called surface plasmon polaritons. When the excitation is strong enough, electrons flow from each cavity and are combined to create DC current. In this way, they have converted the energy of sunlight into electricity. If we're successful, supercell will have many highly desirable characteristics. Their conversion efficiency can be made to exceed the 64% limit of triple junction solar cells. Their performance will not degrade at high temperatures. They do not require any rare or expensive materials, and they should be highly resistant to ionizing radiation. Researchers have already demonstrated individual elements of this process separately. XE is putting these pieces together in a new way. So at XE as a company, we're running on 2 tracks. 1, ramping into production our innovative solar panels, and 2, developing a radical new technology. We're looking forward to the day when those tracks converge, and our supercells sit at the focal points of Sunrise concentrators under Sunstalker trackers to make the most out of every ray of sun. And we hope that you will consider joining us in that effort.